right, day 3, we've got some trig that we're going to cover. I love trig, so it's just killing me not to be there with you guys in the classroom interacting with you, but I'm going to do the best I can, and the trig that we're going to get over the next couple of days is a very surface level. The notes should be significantly less than the last couple of days, and we'll just kind of take it and run with it. So the first thing that we're going to do for our day 3 is just having to do with setting up the ratios themselves and finding side lengths. And we will save finding angle measures for tomorrow. So when we have our right triangles, I have my Greek letter theta here, which is what you will find is representative of the value of an angle from here all the way through math. And in relation to theta, we have a couple of things. We have our hypotenuse, we have our side opposite, and we have our side that is adjacent. Okay, so hypotenuse, our side opposite, and the side that is adjacent that shares one of the sides of that angle. In this case, my theta is down here at angle F. So my hypotenuse is still always opposite of my right angle. And if I look in reference to theta, then my adjacent is down here on FE, and my side opposite is DE. Remember, everything is in relation to that theta that we are given or the theta that we are trying to find. So for sine, cosine, and tangent, you'll see these on your calculator as this. And nothing irks a math teacher more than to hear you say sin. Okay, it's sine, cosine, tangent. Just a little side note there. Our sine ratio is the opposite over the hypotenuse. Our cosine ratio is the adjacent over the hypotenuse. And our tangent ratio is the ratio of the opposite to adjacent. Now, this is SOHCAHTOA, sine, cosine, and tangent ratios. I generally write them at the top of my page as sine is the opposite over hypotenuse, cosine, ca, is adjacent over hypotenuse, and tangent, toa, is opposite over adjacent. This right here is how I write it at the top of all of my papers. I just think that it makes a little bit more sense to see them as a ratio because that is what they represent. When you see something that says find the tangent of A or the tangent of B or the sine A, sine B, so on and so forth, this is actually wanting like a fractional answer. We're not solving for anything, we're merely setting up the problem. So if I look at angle A, I'm going to go ahead and label these. I have my hypotenuse, and in reference to angle A, my opposite will be my 45, and my adjacent will be my 28. So if I want to find the tangent ratio of angle A, that is going to be TOA, opposite over adjacent, which will be 45 to 28, and go ahead and simplify that down, divide them both by 7, 5, no, I can't divide. Let's see, those may not. 45 and 28. You can always use your calculator, math, enter. Yeah, it's stuck. Quarantine's got my brain not working, I guess. Now, I'm going to go back and I'm going to take out those letters. And now I'm going to focus, I'm even going to use a different color, on angle B. So now if B is my theta, my hypotenuse stays in the same spot. My opposite is now the 28, and my adjacent is now the 45. So if I want the tangent of angle B, then the ratio that I'm looking for is the opposite over adjacent. And in this case, the opposite is 28, and the adjacent is 45. Now again, this is not solving anything with trig, okay? It's just a matter of setting up the problems. So I'm going to skip down here to sine. And again, we're going to look at angle R first. So in relation to angle R, I've got my hypotenuse, I've got my opposite, and I've got my adjacent. Sine is the ratio of opposite over hypotenuse. So if I want the sine ratio for angle R, this will be my opposite, 15, over my hypotenuse, 25, which will then simplify down by 5s to 3 to 5. Always simplify it down. And then I'm going to go ahead and get rid of that. If I now want to look at angle S, I still have my hypotenuse opposite of my right angle, and opposite of angle S would be my 20, and adjacent is the 15. So if I want the sine of angle S, I need my opposite over hypotenuse, which will be 20 over 25, and will simplify down to 4 over 5. Those are my ratios. Again, we're not solving for anything. We are just setting them up. And the last set here, in setting up our ratios, if I want the cosine of A, here's my hypotenuse and my adjacent and my opposite. If I want the cosine of A, cosine is the adjacent over hypotenuse. So adjacent to angle A is 48, and opposite to angle A is 20. That would be 24 over 10 and 12 to 5. And then if we do the same thing, I want the cosine of B. My hypotenuse stays. 48 is now my opposite, and 20 is my adjacent. So cosine of B will still be adjacent over hypotenuse, and my adjacent is the 20, and my hypotenuse is the 52. I just realized I did tangent over here, so ignore that. Sorry, guys. And then if I simplify this down, this is 10 over 26, which is 5 to 13. This one over here should have been, that's my bad. Let's see, 48 to 52. Sorry about that. And 26 and 13. All right, my bad. Now, we're going to take these ratios, and now we are going to actually solve for the leg. Remember that our theta always goes right next to the ratio name that I want. So the cosine of A will be replaced by an actual angle's value. Depending on what side we're looking for, that's how we're going to set it up. And we'll just kind of take it in stride. Notice this up here at the top. If you've got your TI calculator at home, you want to make sure that your calculator is in degree mode. So to get there, you will go to mode, and let's see, a few rows down, you have the option for radian and degree. If you will make sure that degree has been selected and hit enter, then you can just click second quit and it'll take you back to your home screen. This is really the only time where degree versus radian really matters, but it does matter. If you start getting a lot of funky answers that really don't make sense, check that your calculator is in degree, because if you're getting all those crazy answers, your calculator's probably in radian mode. It's an easy fix, but you've always got to make sure to watch out for it. So I'm going to be using the Desmos calculator over here on the left. You are welcome to do that as well. This button here that says functions, this will give us our sine, cosine, tangent. And these top three over here on the left are really where we're going to live today. So let's look over here, and we want to find A. So we're given our 57-degree angle. I'm going to go ahead and list out my sides. So this will be my adjacent and my opposite and the hypotenuse. And if I want to find A, I'm going to look and see which side I already have. So I already have the 14. So I have my opposite side and I need my adjacent side. This tells me right here that I'm going to use my tangent ratio. So the way that we're going to work this, it may be a little confusing at first, but I promise you'll get the hang of it. Because I have the opposite and I need the adjacent, I'm going to use the tangent, and instead of putting in a letter, we're going to put in the actual value. Tangent of 57 degrees is equal to the side opposite, 14, over the side adjacent, A. Now, I want you to think back to solving proportions. If I put this over 1, we can solve any proportion by cross multiplying. So I'll show you the long way and then we'll just cut some corners here in a little bit. If I cross multiply these, I end up with A times the tangent of 57 is equal to 14. And if I want to get this A by itself, then I'm going to divide both sides by that tangent 57. So A is going to be equal to 14 divided by tangent 57. And this is what we call our calculator ready format. So I'm going to come over here to the calculator, 14 divided by, I'm going to plug in tangent and then my 57-degree angle. Now we're going to have to round these, and that's fine. Most often we round our angles to the nearest degree and our side lengths to the nearest tenth. So in this case, our side A would be 28.9. Okay, so I debated whether or not to do this. I'm going to go ahead and leave this mistake in here. When I received an answer of 28.9, I, in my brain, did not think that that sounded right. So I went back up here to the top, and if this angle is 57, then it leaves 33 for this side. So my A value should be less than 14, which is obviously not what I got the first time that I worked through this. So what I just finished up saying was that if you get something that doesn't seem reasonable, check your calculator settings. I don't use Desmos very often or really at all for this type of stuff. So if you got that 28.9, you know it doesn't sound right, if you'll go up here and click on this little wrench, and notice down here at the bottom is a little toggle for radians and degrees. Mine was in radian. So when I switch it to degrees, I get a much more reasonable answer of 9.1. Always check that you are in degree mode. Lessons from Mrs. Powell. All right, so now if I want to find B, I'm still going to stick with that 57-degree angle. And now I don't want to use a rounded value, so I'm still going to focus on the 14. I have the opposite and I need the hypotenuse. So that is my sine ratio for 57. So I'm going to start here. The sine of my 57-degree angle is equal to the side opposite, 14, over my hypotenuse, b. And you'll notice here that both of my variables are in the denominator. So I'm essentially, if you think back to our properties of proportions, I can just swap these two. So my calculator ready is that b is equal to 14 divided by sine 57. And now that my calculator is in degree mode, I should be good to go. So 14 divided by sine 57. So b is equal to 16.7. And let's move over to the next one. In reference to 47, I've got my adjacent, my opposite, and my hypotenuse. I'm going to go a little bit more quickly through this one. If I want to solve for x, I have my hypotenuse that I know, and I need the adjacent. So if I have adjacent and hypotenuse, that is going to be cosine is adjacent over hypotenuse. So I've got the cosine of my 47-degree angle is equal to the adjacent x over the hypotenuse 12. So take a look at this one where your variable is. Now my variable is in the numerator. So the way that I plug this into the calculator is going to change. Rather than dividing by my 12 or dividing by cosine 47, think of it algebraically. If I want to get rid of this 12, I multiply both sides by 12. So my calculator ready is going to be 12 times the cosine of 47. So 12 times cosine 47 gives me a value of, let's see, x is equal to 8.2. And again, we're going to ignore this x because we don't want to use something that has been rounded to find y. So now I have the opposite and the hypotenuse, so I'm going to use sine is opposite over hypotenuse. So the sine of my 47-degree angle is the opposite, y, over the hypotenuse 12. So my calculator ready will be 12 times the sine of 47. 12 times the sine of 47 gives me a y value of 8.8, which is reasonable. This is almost a 45, 45, 90 triangle, so it's almost isosceles, so those two should be pretty close in value. Just so that you can see it, I'm going to work this here in green. If I've got a 47-degree angle, then this one down here is going to be 43. I just want to show you that you can use the 43. So let's use the 43 and go back and find y again. So I'm going to switch these up here. This is now my adjacent and my hypotenuse. So if I want to use the 43 with these two, I'm now going to use cosine. Cosine 43 is equal to the adjacent y over the hypotenuse 12, and my calculator ready would be 12 times cosine 43. 12 times cosine 43. And notice that we get the same exact answers for y. So it doesn't matter which of those two angles you use. It just matters that you use the right trig ratio. So whether you want to use cosine with the 43 or sine with the 47, you end up with that same consistent value for y. And 2 more and we are done for the day. On number 9, I have got my 50-degree angle and it wants me to find x. So I have my side adjacent and my side opposite. This tells me that I'm going to use tangent, TOA, opposite over adjacent. So the tangent of my 50-degree angle is the opposite 13 over the adjacent x. So remember, if that 13 is in the numerator, we're essentially going to swap these two. For my calculator ready, I'm going to do 13 divided by tangent 50. Clear these out over here. 13 divided by tangent 50. And that gives me an x value of 10.9. And last one, we're going to do the same thing. It wants us to find both of these legs. So in reference to the 51, I have my opposite and my adjacent and hypotenuse. Let's focus on finding t first. So if I want to find the value for t, I have opposite and hypotenuse. So this is going to be sine is opposite over hypotenuse. The sine of 51 is equal to the opposite t over the hypotenuse 32. So my calculator ready is going to be 32 times the sine of 51. So my value for t is going to be 24.9. And we're going to use these same things and find the value of u. In this case, I have adjacent and hypotenuse. So I'm going to use cosine. The cosine of 51 is equal to the adjacent u over the hypotenuse 32. So to get it calculator ready, I'm going to have 32 times the cosine of 51. Let's see here, cosine of 51. And this will give me a u value of 20.1.